Identify the polynomials. Now again, to identify the polynomials, we have to check the power of each term. And the power of each term should not be a fraction, it should not be negative. So no fraction, no negative. So let's check up the power of each term here. The power of this is 3, the power here is 2, here is 1, and this is x raised to 0, so the power is 0. And thus we see none of them are negative. This is 3, it is not negative nor is it a fraction. 2, not negative nor is it a fraction. 1, not negative nor fraction. 0, not negative nor fraction. So we can say that f of x is a polynomial. Now for g of x. The g of x is given to 2x cube minus 3x square under root x minus 1. Let's write the power of each term. The power of this term is 3, of the second term c is 2. Now the power of the third term, under root x can be written as x 1 by 2. So we see here that none of the powers are fractions. Oh no, this is a fraction, right? So this is now 1 by 2. Since this power is a fraction, it is not a polynomial. G of x is not a polynomial. Let's check if p of x is a polynomial. P of x is 2 by 3x square minus 7 by 4x plus 9. Here power 2, this is power 1, x raised to 0, so power 0, here power 1. So none of the powers are fractions. This is not a fraction, nor is it negative. No fraction, not negative, not fraction, not negative. So p of x is a polynomial. Now for q of x. Polynomial q of x is 2x square 3x plus 4 over x plus 2. I'll write it again, 2x square minus 3x plus, now this is x is in the denominator, I take it to the numerator, x raised to minus 1 plus 2. Now for the power, here power 2, here power 1, here power minus 1, and here power 0. Now this power is negative, and since the power is negative, we can say q of x is not a polynomial. Now for h of x. H of x is x raised to 4 minus x raised to 3 by 2 plus x minus 1. Here the power 4. This power is 3 by 2. Now 3 by 2 is a fraction, and hence the polynomial, hence the expression h of x is not a polynomial. Now for f of x. F of x equal to 2 plus 3 over x plus 4x. Let's rewrite it. 2 plus 3, x is in the denominator and I take in the numerator minus 1 plus 4 of 4x. So here power is 0. Now here power is minus 1, and minus 1 is negative, and since it is negative, we can say that f of x is not a polynomial. Find the 0 or the root of the polynomial in each of the cases. So to find the 0, we have to equate the polynomial to 0. So we have x minus 5 equal to 0. X equal to the minus 5 on the other side will become plus 5. So x equal to 5. So 5 is root or 0. We can call it the root or we can call it the 0 of polynomial. Let's check and see, is it the 0 of the polynomial? If it is a 0 of the polynomial, is in f of x, if we put the value x equal to 5, we should get 0. So x equal to 5 minus 5, the answer is 0. So when you put f of 5, it becomes 0. Therefore, we can say yes, 5 is a 0 of the polynomial. We need to find the 0 of g of x. So for this we do 2x plus 5 equal to 0. So 2x equal to minus 5, x equal to minus 5 by 2. So minus 5 by 2 is 0 or root of g of x of the polynomial. Let's check up again and see, is it the root? So we have g of x equal to 2x plus 5. Now wherever there is x, I'll replace by 5 by 2. 2 cancels. Minus 5 plus 5, yes, it turns into 0. Therefore I can say minus 5 by 2 is a 0 of the polynomial. Now here we got to find the 0 of h of x. Now 2x equal to 0. So x equal to 0 by 2, x equal to 0. So 0 is the root or 0 of polynomial. Now we have to find the root of p of x. So we do cx plus d equal to 0. So cx equal to minus d. So x is minus d over c. Say minus d by c is 0 of p of x. Let's check up and see, is it a 0? So we know p of x is cx plus d. Now wherever there is x, we will put minus d by c to check if it is a 0. So c for x, I put minus d by c plus d. So this cancels out. Minus d plus d equal to 0. Yes, it is a 0 of the polynomial. Now we need to find the 0 of p of x. Now p of x is ax. So we do ax equal to 0, x equal to 0 by a, x equal to 0. So 0 is the 0 of p of x.